in 6 months after you have written a program and you need to go back and edit it. Okay, I have created this little challenge here for you. If you want, you can go ahead and pause the video and open up your text editor and see if you can create this little program right here. So we want to, one, create an input with a greeting. So just say, hello, what is your favorite food? Let them put it in, and then take another input and say, what is your favorite hobby? And store that also in a variable. And then we're going to print with an F string their favorite food and their hobby. So if you want to give this a go, you can go ahead and give it a try. If not, we will start it now. So we're going to start out with create an input with a greeting. So we'll just say print hello. And then we're going to take an input, but we got to save it as a variable. So we'll save this as food, and it's going to equal an input. And inside the input, we're going to have the question, what is your favorite food? Question mark, space. I see that we have a typo here on all three. And then that's going to be saved as their food. Then we're going to say input, and this is going to be, we'll just save this as hobby, and we're going to take in input, and we're going to say, what is your favorite hobby? Question mark, space. And then we're going to print with an F string all of this together, and we'll say print your favorite food is, and then if you remember, we need our F string here, and we should grab our curly braces and say food and your favorite hobby is curly braces hobby. Now when we run this, if we did everything right, it should print for us this final statement after we give these inputs. So we say run, and it says, hello, what is your favorite food? And we'll just say chips. What is your favorite hobby? Running. And it says your favorite food is chips and your favorite hobby is running. So this is a simple input form, and it's going to print out with our variables that we have stored. And this is a good practice because when you write a program for a tool maybe that you develop in the future, you are going to want to know how to do inputs, so that way you can take the input, save it in a variable, and then later do something with it. So later on in the course, I'm going to give you a practical example of taking input and then running it in a program that is really helpful, and I will cover that when we are ready for it. All right, so we have covered the string so far. This integer is a whole number. So if we say int, we have a number of 7. Floats, we're not really going to use these a whole lot in the world of cybersecurity. They have a point within the number, so 3.14 would be an example of a float. To date, I cannot remember a single time I have used a float in cybersecurity. Usually that's more towards data science or something of that nature. A Boolean is true false. You will want to remember Boolean. We'll cover these a bit in the future. When we do our while loops, we'll be using the true false. So these are some of the different data types, and just to get an idea of what these look like, if we save a variable and we make it a float and we say like 1, 2, 3, and then we print this, it will tell us what we have. So we can come down here and we can say print, and then we can put type, and then we can put in our variable, and when we run this, it will tell us that we have a float. And if we put in an integer, it will tell us that we have an integer, and then so on and so forth. We can do this with an int, and then we can also do this with a string. And we can hit run, and it tells us we have a string. Sometimes we will do something like this, and then we have this saved as a string here, and then when we go to add this to something else, we can get an error, and it's because we have a string and we'll be trying to add together a string and a integer, and it won't work. So we'll go variable 2 equals 3, and then when we say variable 3 equals variable 1 plus variable 2, we're going to get an error, and it's going to tell us that you can't add these together. So this is one version of how these matter. Another version of this is, let's say we want to print, and we say we have an integer right here, and we want to add it to a string, and we can go like this, and we say 70. What do you think is going to happen? It tells us we can't add these together. But if we take this and we turn this into an integer, what will happen now? Now it works. So this is the difference. So this is an integer, this is a string, unless we declare it to be an integer. And you can do the same thing with floats, so I'm not going to cover those. And then what happens if we do this right here? What do you think the output will be? And the answer is 7070. So this is the difference between integers and strings and how they work with numbers and data. So if we wanted to, we can turn both of these into integers. And this is the last example. I promise I don't want to bore you with adding these together. And then we say enter, and we're back to 140. So this is a little bit of strings, integers, and booleans, and we'll kind of skip floats because I don't think we'll really need them, but it's worth mentioning so you know they're here. And with that, we will continue on with our next challenge. Okay, so we have these numbers here, number 1, 2, 3, 4, 5, saved as num1, and then num2, and then num3. What I want you to do is to write this to your console, or write this to your text editor, and then I want you to add this variable plus this variable and see what the output is. And then I want you to take the second number in num1, so it would be this 2 right here, and I want you to add it to the second number in num3, which is this 7. So your output should be 9. I want to see if you can figure that out. And then the third challenge is to take num2 and change num2 into a float and print the type to the console, so that way the console tells us that it is a float. So if you'd like to go ahead and pause and give this a try, you can do that now, or we will go ahead and tackle this right now together. So what we are going to do just first is we're just going to print, and we're going to say we're going to turn this into an integer, and we're going to go and write in num1, and then we'll add this as an integer, and then we will say num2, and this needs to be closed off or we will get an error, and this should print it for us. So it tells us here is the total if we add those together. And then the second challenge is to add the second number. So we'll just take this, just a heads up, copy and paste in programming is always a bad idea, because if I have a bug here, I just now copied and pasted it and I have 2 of them. But what we're going to do is we're going to take this and we're going to put in our square brackets. And if you remember, it says 0, 1. So we're going to say 1. And then we're going to say 1. I guess I didn't really need this. And then we'll print this. And our output is 9. So now we've grabbed the second numbers. And then our third challenge is to change number 2 into a float so that it prints float. So what we want to do here is just say print, and then we're going to tell it we want a type, and we want to print out the type of num2, and then above that we're going to just type in num2. You can do this 2 different ways. I'm going to do it this way. I'm going to say num2 equals num2, and we'll just go like this, and we'll type float, and we'll close this off. And now if we print this, it tells us it is a float. and we will continue on with our Python course in the next section. Okay, we are going to do a walkthrough of if, elif, and else statements. So this is the instructions for the little program I'm going to write. But when I finish this program, I'm going to give you a challenge to do something similar on your own. So I'm only going to give one example. You're going to need to pay attention and maybe watch this walkthrough twice and then go on and try the challenge. So the first thing we're going to do is if you are under 5, you are a kid. So our if statement is going to first need an input from the user that is going to tell us what is their age. So we'll just say we have a variable and we want it to be an integer, and we want an input, and we're going to ask them, what is your age? Question mark, space, and we have to have that space, otherwise it's really ugly in the terminal. And then we're going to start our if statement. So we're going to say if this person's, their input, which is their variable, is less than the age of 5, then we want it to print that they are a kid. So we'll print, you are a kid. Now, one thing we want to do is if they hit the age of 5, we'll need an equal sign here. Otherwise, I'll just show you. If we say, we'll need an else statement so this doesn't error out. Actually, we'll just let it error out. We'll say, what is your age? And they say 5. And we get no output because this doesn't include 5, remembering that the computer starts at 0 and then it's going to stop at 4. So if we want to include 5 in as yours a kid, we'll need that the variable is less than or equal to 5. Now if we put the 5 in here, it will print for us, you are a kid. So what we need to do next is we're going to type in elif, because we're going to make an elif statement, and we're going to say the variable is less than 15. And the reason we don't have to worry about anything under 5 is because it will catch this if statement, and then this whole program we write after this will stop and the computer will actually skip it. So we don't need to worry about adding anything else in here. And we can say, actually, if you are less than or equal to 15, then we are going to print you are a big kid. And then for the final elif, we will say the variable, and we will say if it is greater than or equal to 21, and that's ugly, and we will say print, and we're going to print you are a bigger kid. And now we're going to put in an else statement, and in our else statement we're going to print anything that's over 21. We're just going to print you are old. So now if we run this and we rerun the program, we run it and we say how old are you, and we say 3, we get you're a kid. If we say 13, we get you're a big kid. If we say 18, we see you're a bigger kid. And if we say you are 44, we get you are old. Now, because we're going to be using this as a tool for us to be able to write tools and modify tools, I'm not going to cover this because I think that it's not really necessary for cybersecurity. But if somebody were to run this and they put in the letter A, it's going to crash our program because the letter A is not a number. It's not an integer. So what we'd have to do is we would have to make this so that if they put this in and it was an A, it would print, enter a number, and then rerun. But we're not going to do that because it's not really necessary for cybersecurity. It's just something to be aware about. Now, what's coming up is your challenge. Let me delete all this and I will write up your challenge for you in the next section. Your challenge here is to take the temperature from the user and then tell them if it is less than 20 degrees, you need boots. And this is from the US, so I'm running in Fahrenheit, not Celsius. And if it's less than 30, you will need a coat. If it's less than 70, you will need a jacket. If it's over 70, it is nice outside. So take this input or take this information and make a program with if, elif, and else statements. Okay, so here is how I would go about doing this. I would take an input and it will say, what is the temp outside? And this will need to be an integer, because we're going to be comparing this as a number. So we'll say if var is less than 20, then we're going to print you need boots. And we'll say elif var is less than 30, print you need a coat. And then we're going to use one more elif here. Elif var is less than 70, print you need a jacket. And then finally we'll do else, and it's above 70, then it's nice out, and we don't actually need to put anything in there because this is an else statement. So everything that's above 70 will automatically print it is nice outside. So when we run this, if we put 12, we need boots. If it's 22, we need a coat. And if it is 65, we need a jacket. And if it's 85, in my opinion, it's perfect outside. So this is the if and the elif and the else statements. We're going to be moving into for loops, and later we're going to look at nested if statements, and they'll look something like this. If it's less than 20, and then we can say if var is less than, we'll say it's greater than 25, then we can print you need boots, and then we'll print something like gloves. So nested if statements look something like this, and you can have nested if statements just so you're aware of it. So if we say it's 26, it will, because we're hitting this one, we'll say this is 15. So if we say that the temperature is 16, we hit you need gloves and you will need boots. So this is a nested if statement. We'll cover these a little more in the future. I don't know how much you will need these nested if statements. I use them every now and then, so it's nice to know that you can run nested if statements. But for now, we're going to move on to our for loops. Before we get into for loops too far, I want to show you why for loops are important, and I also want to show you why lists are important, which we're going to be going over here in just a minute after we get the basic understanding of a for loop. So this is a program. I've shown it before. Don't worry about what it looks like. It looks kind of complicated, but it's really not. What happens is you put in a repo that you would like to target on GitHub to go and search for all of the usernames, passwords, and files that just shouldn't be made to the public. So in this case, it's looking for passwords on GitHub. But what we have down here is a for loop. So this for loop right here, we have an empty list, which we're going to cover in a second, and it goes out to GitHub right here, and it will go through all these links, everything you can click on, and it's going to narrow it all the way down to the repositories, and it will click this link, and then it'll click the file, and then it will click the raw, then it copies this entire thing, and it puts it into a CSV file, and then checks for the word password. So that's the program itself. But what's important to remember is what happens is it goes out and it pulls all the links and puts them in a list. Then it goes through this for loop and it takes all of these, and it says for every one of these items that is inside of the links, which is actually this variable that I have up top, it's going to do something. So for loops are very important. You can see I have another one right here. So for loops, we are going to need them. Lists, you are going to need them as well. And I just wanted to show you this because sometimes what happens is you'll be going through trying to learn something, and I'm showing you something very elementary, and you are like, why do I need to know a program that tells me to put on a jacket? This is all building up to something that is going to be able to help you build tools, and more specifically, if you're new, just be able to read through exploits and be able to edit them, because you're going to need to know how to read Python and edit exploits as you grow in the world of cybersecurity. So here is a very basic for loop. And I'm going to show you it in a string because we've already covered strings. And what all this does is we have our variable string right here that is holding hello world. And so the way the for loop works is it says for I in string. So this I right here is going to be another variable that holds one letter each time the for loop runs. This I is going to represent one letter, and in a list it's going to represent each item in the list. So this will run. I'm going to run it so you can see what this looks like. The way it runs is it goes for I in string, so it's going to grab the first letter, which is going to be the H, and then it prints it. But the for loop is not over, so it runs the loop again, and it'll grab the E, and it'll print just the E on a new line, and then it goes through and it runs every single time until it is out of things to run, and then it closes the loop. So this is how for loops work. I'd like for you to go ahead and write out your own for loop and maybe put something different in here and try to get an understanding of how it works. And if we wanted this to print all of this together, you would have to store this into a new variable and then print it outside the for loop down here like this. And this is where we would print our new variable. And we're going to cover this in lists because this is something that you will need to do in the future. So go ahead, play around with the for loop, write one, get an understanding of how it works. If this doesn't make sense, rewatch it, and hopefully it makes sense. I know after teaching for loops to several different students that for loops sometimes can be hard to understand, but they are really useful and something you need to learn. So we're going to be covering lists in the next section. We're going to be looking at lists, and a list is something that is going to be useful because we're going to be appending to lists all the time within our for loops. So a list can look like this. My list equals square bracket, and lists always go inside of square brackets, and we can say item 1 and then comma item 2, and then we can do an item 3. So we have our list here, and if we want to run a for loop through this list, we will say for I in my list print I. And now if we run this, it will run item 1, item 2, item 3. So this is a list we will be using these in the coming lessons, and they will be helpful for you in the future. As you've seen in this program, I have two lists right here, and they are used regularly to append to. So lists is something you will need to know. So go ahead, make your own list and see if you can loop through your list, and maybe try and just print something like this later. Just print the item 2. So you'll have item 1, 2, 3, and then print number 2, and see if you can remember how to do that. If you have forgotten, it would look something like this. Print, and then we can say my list, and then we can put this in square brackets, and we'd say 0, 1, and then we have a 1, and now we could print this, and we have 1, 2, 3, 2. So that is going to be it for the lists. We're going to move on, and we're going to start using lists in a more comprehensive manner. So we're going to try a while loop now, and the way we're going to do a while loop is by using a Boolean. I like to set a variable and then set it to true, and then at the end of the while loop I will set it to false. So the way this works is make a variable, and we'll just say variable, actually we'll name it on. That's a good way to name the variable, and we'll say on equals true, and then we'll say while on, and we'll make a variable, and we'll just call it variable because I don't know what to name it, and we will take an input, and we will say continue running while loop, and then we will put y, we'll put a y or a no. So would you like the while loop to continue, yes or no? And then we can say that we can go do something like this, and then we can set a variable up here and say I equals 0, just so you can see how many times this is running, and then we'll say I plus equals 1, and then this should just continue to run, and then we'll put an if statement, say if the variable equals in, then we'll say that on equals false, and this will kill our for loop. So now if we run this, it'll say would you continue running the while loop, and we will say yes, 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 and then when we say no, it'll kill the while loop. I forgot to print our I so that we could see this. So now we can say, would you like to continue? Yes, yes, and you can see our variable, every time the for loop runs, our I gets added to 1. So our for loop has run, now it says 7 times, 8 times, 9, 10, and then when we're done, we can say no, and we can end it. We are going to be starting functions, and just to be clear, I have not pre-written any of the code we're about to go over, or mostly anything we've gone through in this course. That's why you've seen me make mistakes. And so as we start functions, I'm going to try and make this a little more realistic for us, so that when we are thinking through functions and writing code in the realm of cybersecurity, you can start to get an idea of how this can be used. So we're going to start with functions, and a function just calls something very specific that we want to happen. So we can just say, we'll call it my function, and then the way your function is going to start is with a def my function, and then we close it off like this. And then down here, we want our function to do something very specific. So we can say print, and then we can say it worked. And the way a function gets called is usually somewhere further down inside the code, something happens and it triggers this function back up above it for it to actually do something. So what would happen in order to call this is we would just say my function. Now when we run this, when the computer reaches this right here, this closing bracket right here, I usually like to think of this as the call sign for the function. So if we run this, it's going to print it worked. And this will become more clear as we write more of these, but this is the basic concept of functions. And one thing we can do with functions is we can pass through variables. So we can say something along the lines of I, and then we can say or we'll make it a different variable. We'll say variable equals I plus 3, and then we can say print, and then we can say we want to print our variable. And so in our function, we can pass information through like this. So when we say my function, we can now say input, and then we can say, what would you like to add? And because this is a string, we're going to need to make this into an integer. I guess we can go and make it an integer right here, and we can say int. And then we can close this off. Now when we run this, it's going to ask us what would we like to add, and we can say 3, enter, and it'll say 3 plus 3 equals 6. So this is a very basic function. So we take some kind of input right here. This is where we call our function. So now this function is being triggered, but we want to pass something into our function, some kind of variable or some kind of information that we've grabbed somewhere else. And what happens is it can now use this inside the function. This, you may be thinking, like, in what case would I possibly ever need to use this? And so I'm going to just show you my GitHub dumpster diving tool, once again, that I've used multiple times on this channel. This right here, where it's grabbed a repo, I call this function, and it's going to loop through to see every single file inside of the repo. Is it a Python file? Is it a JavaScript file? Is it an XML file? And what happens is when I pass this repo through, it now is able to use this variable that has come from somewhere else inside this function. And then I do the same thing up here. I pass through a variable inside of a function. So this is really important to know, and you will use it. And we're going to go ahead and give another example. And actually, before we give another example, I want you to try and write your own function and see if you can get it to take an input. So let's take the input and make it the first letter of your name. So I'll write out the instructions. You want we'll say first letter of your name, and you want to take this as an input. So we'll say input, and then you want to call a function that adds your first letter to the rest of your name. So here's your instructions. You're going to make a function, and then it's going to take a variable, and that variable is going to be the first letter of your name, and then you're going to add that to the rest of your name. So I hope this makes sense, and I'll go ahead and walk you through what this would look like. So we'll go def my function, and then we're going to call this function. We're going to pass through, let's use I as our variable, so that stops giving us, whenever this is giving us an error and I can't stand looking at it, I type in pass, and that will not give us the error, and we'll come back and delete that in a second. And we're going to call my function, and we're going to take another input, and we're going to say what is the first letter of your name, question mark. Now we can delete this, and we're going to come back up here, and we're going to use this, and we're going to say that my function, and we're going to take this input, and it's going to be a pass through as I. And so down here, we're just going to say my first name is Ryan. So we will say we'll call it the variable equals I plus, and then we can put the rest of this inside of a string, and we can say something like this, and then we can print our variable. So when we run this, if I put an R in here, it'll print out my name. So I hope you're able to figure this out. Maybe try to come up with another way to write a function and practice writing functions and see if you can get the hang of it. And in the next section, we're going to go over something that will show you how this can be really helpful in building your own tool. Okay, I hope you have played around with functions and you are now ready to try and become a little more advanced, and we're going to try and gear it towards cybersecurity now. And I hope you're familiar with maybe the Nmap scan and some other tools. So we'll just use an Nmap scan right now, and we'll just say, like, we're going to call a function and we'll call it Nmap. And this is going to take a variable, and we'll actually call it the IP because we're going to take an IP address. And the way I like to run my Nmap scans is with they'll look something like this: Nmap -a, like this, and then we're going to pass in the IP address, and then I like it to be verbose. Now, in order to get this to run, we would have to import a module called OS, but we're not ready for that. So this is just to show you how the functions will work. And so I will wrap this entire thing inside of curly braces. I got dashes in here that shouldn't be there. I don't know why I did that. And then we'll wrap this inside curly braces. This is not supposed to be inside curly braces. That is supposed to be inside of quotes. We'll make this an F string, and we'll say our variable equals. Instead, this would be an OS command if we were actually going to run this in our Linux machine or Windows, whatever you choose to use as your hacking VM. And now what we'd do is we'd come down here and we would say something like Nmap to call our function, and then we're going to take an input and we're going to say, what IP would you like to scan? And then right here, we are going to print running Nmap scan against, and then we will put in the IP address, and this will need to be an F string. So the way this, that will not be the IP. That will be against the variable. So it will tell us that it is running the Nmap scan right here. Okay, so when we run this, we can say who would we like to scan against, and we'd say 192.168 point something else. And then when we run this, it'll print running Nmap scan against, and then it gives us the output right here. So this would be a way that if you were trying to write your own tool to automate your recon, this would be one of those ways you would use a function in order to automate your recon. And there's a lot more you can do with this IP address, and you could pass it into multiple different tools, and then you have written your own tool. So this is how we can use functions in cybersecurity that are really helpful for us. And whenever you're going for a certification, it'll be really helpful for you to be able to read through functions and maybe modify them, especially in exploits, because vulnerabilities and exploits change over time, and you will need to be able to change and modify different exploits that you come across on Google in order to gain access to a machine. Before we end this course, I want to give you a little bit of an introduction into making your own tools, and then I want to challenge you to add to this recon tool that I'm about to show you, and you can start to build your own tool for recon, and it'll help you remember the Python code that we've gone over so far in this course. So I've gone ahead and connected to HackTheBox and launched the box devel. And so I want to just show you what OS system does. So we'll import OS system. You've seen this before, and this is just our operating system. It just means we're going to be able to tell our Linux machine to carry out commands the exact same way you would inside of a terminal. So we're going to make a function, and we're going to call it recon, and we're going to pass through an IP address. Really, if you remember, this is just a variable that we're going to be passing through into the function, and then we're going to call our function down here, and we'll just call it recon, and then we're going to ask for an input, and then we're going to say, what IP would you like to scan? And then we'll put a question mark and a space there so that way it's not all smashed together. And now inside of here, what we can do to make this program run our recon and automate it for us is we can type OS system, and then we can put in here, we're going to make this an F string, what we want to do. So we're going to run an in-map scan, and we're going to run it on all port, or we're going to want all outputs. We're going to run it on all ports, and just in case it is blocking the ping, we'll put the P in. You don't have to put this in here, it's optional. And then we are going to put in the IP address that we run through, and I really like to run everything as verbose. So this, when we run this, you'll be able to see, it'll say, what IP would you like to scan? And I'll put in the IP address, and it will now start the scan for us. So this is the same thing we would see inside the terminal. We're going to see port 80, port 21 is open, and at the end of the scan, it will tell us everything that has happened on this scan. Now you can add to this, we'll stop this, you can add to this same scan. When it gets done running the in-map scan, you can come down here and maybe you want to look for different directories, and so you could go os.system, and we're going to make an F string, and we can add in, maybe we want it to run derb, and we want it to run on the same IP address that we've already passed in, and it will now launch this right here as soon as it gets done with nmap. And the cool thing about this is if you have your own recon tool set up, you can go ahead and run the program, send over the IP address, and then you can leave and it will automatically run your recon. Or maybe while your recon tool is running, you can do other more manual enumeration. Maybe it has port 80 open and you see that real quick with the nmap scan, and you want to start looking at what's on port 80, and it will run your nmap scan, it will run your dirbuster for you, and maybe you want to run wfuzz, or maybe you want to run sublister. I want you to go ahead and start off with what I have given you right here, and you can add to this tool with the information that you have learned so far. Okay, so in this video we're going to be covering enumerating APIs or backend APIs, and I see this in bug bounty programs sometimes, and I'm sure you guys have come across a page that looks exactly like this. You come in, you go to the URL, and you get some JSON in return. And I actually was looking through a bug bounty program just a few days ago, and I actually saw it said backend and then api.theprogram.com. And so if you're new and you're not really sure how to enumerate APIs, then this video is going to be for you. We're going to keep it really short and specific so that way you can go out and do this yourself. We're going to be looking at the box backend on Hack the Box, but we're not actually going to walk through the box. All right, so I have decided to include this little section here on making a GitHub recon tool in Python for you, because I figured if you have went through my first bug bounty course, I had this section on the understanding the basics of Python. And as you become a more well-rounded bug bounty hunter or penetration tester, your programming skills are going to improve as well. So I decided this tool was easy to make. It includes a lot of really easy concepts within Python, but it is actually a lot of code, I guess, if you are a beginner. If you're going to continue down the road of penetration testing or bug bounty hunting, you're going to want to develop your own tools and have a better understanding of Python, and I figured this was a really great tool to give you an idea of things you can actually build that are useful. And even with this tool, you can add on to it and make it your own and give it new functionality. So I've decided to include this in here because it will help you and save you time in the future if you decide to continue bug bounty hunting. So enjoy this tool and use it well. Okay, so the setup for Selenium is going to take a little while, and I don't want you just to close out and think this is too hard. I want to show you how cool this tool really is. So if you follow along with this video, in the end you're going to have a program and you're going to understand all of this code, and then you're going to have a program that goes out to GitHub for you and goes through the repos, opens all the pages, goes through all the links, and pulls out if there's any passwords or not stored in the code on the GitHub page. And so it will look like this when you run it. And it automatically went through all of those links on GitHub. It pulled down this page right here. It says a password was found at this link. And so if we click on this link, it'll take us to this page right here, and we can look at this and we can go to the raw and we can type in password, and right here it tells us it has found password, and the password is admin, and it found this on this GitHub page. So that is where we're going. And if this tool looks like something you would like to add into your bug bounty or penetration testing arsenal, then you can stick around and go through and make this tool with me. We start with our program and using Selenium. There's a few things that you have to do, and I'm going to walk you through installing this both on Mac and Windows. You will need your PyCharm editor that we used in the first Python for Ethical Hackers, and now you are going to need Google Chrome installed, and so I'll have this link down in the description. If you don't have Google Chrome, it is best if you use it. You can also do it with Firefox, but it's really easy if you just download Google Chrome and follow along with me. And we're going to also need to install the Chrome web driver. So what you will need to do is download the version of the Chrome driver that matches your Google Chrome installation. In order to find out what version of Chrome you are running, you will come up here, click the three dots, you will go down to help, and you'll click about Google Chrome. And then I am running this version right here. In order for me to update my Google Chrome, if it doesn't match any of these over here, then I would just have to close out of Chrome completely. You just go and close the app and it will automatically update. And I am running this version right here, 101.0, and I would come back over here and I would say 101.0. For me, it would be this one. I would click this, and then it will bring you to this page. It looks exactly like this, and it will tell you what version of software you're running, and you will click that version. So if you're running Windows as your operating software, you click Windows, Mac, or Linux. For Mac, I use this one right here. And when you install it, remember where you put it, because we are going to need to know the complete file path in order to reach the Chrome driver. I have mine stored right here in a folder on my desktop. So if I open this up, I have my Chrome driver right here, and I will need to know where this is. We will need to know the entire path, and you can do this. You can see the full path by right-clicking and going to Get Info, and then it will tell us where the full path is at right here, because it tells us where, and then we say Mac, user, Ryan, desktop, the folder is developer, and then we hit the Chrome driver. So you'll need to go ahead and install Google Chrome and then install the Chrome driver, and we will continue walking through how to finish setting up Selenium when you have finished doing that. After you have downloaded the zip, go ahead and unzip it, and it will automatically unzip into your downloads, and then you can drag it into a different folder like I have. I've just made one called developer, and you can go ahead and drag yours out of your downloads, or you can leave it in your downloads if you choose. The only reason I move it out of my downloads is because sometimes I go and delete everything out of my downloads folder, and I don't want to delete this if I am using it. For the Mac users, after you've downloaded this and you have moved it into your location where you would like to keep it, for me, I'm going to just go like this. I will open back up this folder. I'm going to show you what we did earlier. Just go to Get Info. You can now copy this as your full path, and then we can say our Chrome driver, so we'll go CDP for our path, and then you can paste it in here just like this. And I believe we need to go slash Chrome driver. So we'll go slash Chrome driver. And this entire thing will need to be inside quotations. Now I'm going to cover the installation of Selenium for Windows users. Okay, for our Windows users, what we're going to do now is click Chrome driver Win32 and it will download. We will open up where this is. It's going to say how do you want to open this file? We'll just go ahead and open it. It says we now have this Chrome driver and it tells us that this is an application. If you don't have any place in particular you want to store it, go ahead and put it in your C drive. But before we do that, we'll just open this up. We will make a new folder and do the same thing we did on the Mac, and we will say developer, and we'll just leave this here, and we can go back to our downloads where we grabbed this folder and we extracted our Chrome driver, and we're going to put this into the developer. Now the reason I had you do that is because when you look at the location of where this is stored, it is really simple to get to. It tells us that it is in C/developer. We can copy this. We will put it inside of a string, and then we will put slash, and now we will do the same thing we did on the Mac, and we will say the Chrome driver path, and now we have that stored as a variable. Sorry to my Windows friends, I forgot to mention that when you run this Chrome driver, you will need the .exe in order to get the executable to run, and pretty much everything from this point on is going to be the same as I run it on my Mac. If you have any problems, please let me know in the comments and I will try to help you out. Okay, we are ready to install Selenium. So the way we're going to do this is we're going to import Selenium just like this, and because I have done it before and I have already installed it on my Mac, this is here and ready for me. But what you may need to do is it will have a red squiggly line and it'll pop up a window like this, and you're going to click install or import. I can't remember which it is, but I think it's install, and you'll click install, and it will take just a second to go ahead and install that. And then what you're going to want to do is type in from Selenium, and then we're going to import the WebDriver. Now that you have installed Selenium and typed in from Selenium import WebDriver, we're going to initialize our WebDriver, and we're going to type in driver equals WebDriver.chrome because that's the browser we're using. There are other browsers if you've chosen to go that path. And now we're going to type in our executable path. And the reason this is yellow is because this has to be capitalized like this. And we're going to type in executable path, which I believe is actually deprecated. And I have not gone back and read the documentation for the new way to run this without the executable path, but we're going to type in CDP. It's just going to give us a error when we run this, or it's just going to give us a warning saying that this version is deprecated for running the WebDriver, but that's okay. We will get our program to run without it. It just means that they are not updating the executable path like this anymore. And now what we're going to do is type in driver.get, and we're going to type in something like www.google.com. And then once this is done, we're going to want our driver to close the window. So you can type in driver.close, but I don't like to use driver.close personally because it just closes the window, but we will be still running the Chrome down here in our browser. I want it to quit. I want it to close that window all the way out to save on my memory space on my Mac. So we're going to type driver.quit just like this. And if you run this like I will and you are on a Windows, it's automatically going to run for us. It should open without any warnings and give us google.com, and then it will close this page for us. All right, the reason this is giving this error is because we need to type in https://google.com. Now when we run this, it should open up Google for us and close the file. So that is how we run it. But if you're on a Mac, if you're on Windows, that worked for you and you didn't get any problems. If you're on a Mac and this is the first time you've ever ran Selenium, you're going to get a little error that pops up with a window, and it's going to say move to trash or cancel or close. You're going to click cancel or close. Out of your two options, you're going to come up here, you're going to go system preferences, you're going to go security and privacy, and right here it will say that you tried to run a Chrome extension and it was blocked. You will click allow. If you're not allowed to click allow, you can unlock it by clicking this and typing in your password to unlock your Mac, and then click allow, and then you can relock it. Then when you close out of this and you rerun it, it will give you the option to open anyway, and you'll have a new pop-up, and you will just click open and it will begin running and working for you just like this on your Mac. Now it is time to begin some of our web scraping. Okay, so we are at our screen and it looks like this. I've decided to go ahead and show you how to get rid of this deprecating warning. So when we run our program and it runs this right here telling us that the executable path has been deprecated, just in case they stop using this in the future, I want to go ahead and show you the way to get rid of this. I'm going to use running the executable path because I believe that it is faster, and I might be wrong, and that's okay. And you can run Selenium however you choose. You can run it the deprecated way or the current version. I think they're at version 4 if you choose. But we'll have to import a few more services from Selenium. So we'll go from selenium.webdriver.chrome.service import, and then we're going to import service, and then we're going to need to import the Chrome driver manager. So we're going to go WebDriver manager.chrome, and we're going to import Chrome drive manager just like this. Now I'm going to comment this out because I'm going to use it as we go through, but you can delete this if you want to use the non-deprecated version. And I think you're still going to get these red inputs down here, or these red warnings that's going to tell you like it's installing the newest version of the WebDriver every single time you run it, but that's okay. And we're going to type in s equals, and then we're going to type in our service, and then we're going to run our Chrome driver manager, and we're going to call this, and then we will call the install function. And the reason we're going to do this is because every time you run this service, it is going to check to see what version of Chrome you are running. So we'll just comment this out so we're not getting this warning. And this dot needs to go, I did this wrong, we'll go like this. All right, it is not wanting to work for me, so we'll close it off manually, and then we're going to hit dot install. Right here, we're going to call this method, and then we have to close off this whole line here. And now we're going to turn this over to our driver, and it's going to equal the WebDriver.chrome, and then we're going to use the service, and it's going to equal s, just like this. Now, if we uncomment our driver down here, we'll have no errors, and when we run this, it will now work for us. And it's going to tell us we are using, this is the version of Google Chrome that we're using. If you remember, we checked our version earlier and then we installed the Chrome driver, and it tells us we have the Chrome driver that matches our version and it is found in cache. So it now works. This is the non-deprecated way to run this tool. I decided to go ahead and show this to you, like I said, just in case the way right here, the deprecated version to get to the Chrome driver is no longer supported in the future. All right, I have gone ahead and commented out this code, and I'm going to use the Chrome driver that is on my computer that we already installed. There's one more thing we're going to need to import in order to not get any deprecation errors, and that is the by. We're going to import by. So we're going to type in from selenium.webdriver.chrome, or sorry, not Chrome, .common, and then we're going to use by, and then we're going to import and then by like this, if I can get back there, like this. And this is another update with Selenium. The way I originally learned Selenium, we didn't have to use this, but they have updated it again, so we will need to use this buy module here. So what we're going to do is open up Amazon, and I'm going to show you how this scrapes. If you've ever wondered why you have to answer questions to make sure you're not a robot, you're going to find out in this course. So if we come over to a web browser and we type in Amazon, and we go to Amazon, and let's say we want to buy a new drill bit. So we just say we want a drill set. Okay, we're getting a drill set, not a drill bit. And we click on this drill, and we really want this drill, but we don't want to pay $43 for it. We want to pay $38 for it. We can actually set up our WebDriver to go out and check this price for us. So what we would do is we would inspect this, and we can look for the class right here, and it's going to tell us that it's 43. So you could set this up. Let's say instead of 43.99, we don't really care about the 99 cents, and we just want it to be less than 38. So 37.99 would work. We could use this span, but for the sake of getting the 99 involved, we will use this one right here for our project. So we'll go ahead, click on this, and we're going to use this class right here. And we're going to grab a class out of these right here, and we want to grab one that looks really unique, that isn't going to be used anywhere else. This class looks really unique to me, so I'm going to go ahead and copy this, and then we'll come back over to our Chrome driver. And underneath of our google.com, we're going to type in price equals, and then we want the driver to scan through all of this source right here, the HTML, and we're going to tell it we want to find an element, and we want an element by a class name. So we want to make sure we don't have elements by class name. We want a single element by the class name. Later we're going to use the one with the S, and this is the deprecated version. I forgot this is the version that I learned when I was using this. What we do here now is we delete all of that, and we delete that, and we come in here and we say by dot class name, and in here we're going to put that class name that we just copied, just like this. The next thing we need to do is update this HTTPS right here, and it needs to be this URL right here, so that way our Chrome driver opens up the right URL, scans through all the HTML. It's going to look for the class name that possesses this, and then we want it to print the price like this. So we'll say print, and then we want to print the price. So if we run this, how it is right now, I'll show you what our output is. It gives us this as our output, and this is not helpful. So what we need to do in order to grab the plain text is type in text. So now if we run it, it's going to print out for us our $43.99. And I'll show you what would be useful if we're really going to turn this into a web scraper for us. It really would be useful to get rid of this 99 and just use this right here. So you can see why it's printing the way it is. This span, 43.99, and it's given it to us on different lines. So we should be able to copy, let's try this class right here. And this really is, when you're making these, going to be a lot of trial and error, as you're going to see in a little bit when we make our new dumpster diving ethical hacking tool and we try to automate some of our recon, where it's going to be a lot of trial and error. So we'll let this run, and we get the $sign. That is not what we want. So we'll try this one, and we will paste this in here, and now we can run it and see what comes back. and we grab just the 43. So now if we wanted this to run, say every 20 minutes to see if Amazon has updated their price and brought it down below $38, we're going to put all of this inside of a function that is going to get called every 20 minutes, and we're going to have to import a new module for this. And we're going to do that in the next section. All right, now that we have our web scraper working, let's say we wanted to go out and check the price every 5 minutes or 30 minutes or whatever we want it to be, and then let us print it into the console. What we would do in this case is put this into a while loop. And so what we can do is take this and we can say while on, and then we want the on to be true all the time. So we'll say on equals true, and this should be familiar to you if you have gone through the first part of our Python for Hackers. And then we're going to need this inside of a function that gets called every 4 seconds or 30 minutes. And we'll need this inside of a function that gets called every so many minutes. In our case, I'm going to set it to only 5 seconds. So that way we don't have to wait very long. But in a real case scenario, you would make this run maybe once a day or every couple of hours to check the price. But for now, we're going to make a function and we're going to call it 5. We'll call it 5 seconds. We'll call our function. And then we will need all of this to be inside of our function. And now we need to call the function like this, and we will say 5 seconds, and then we are going to take this and we need this to sleep. So we'll say time.sleep, and you will need to import time up here if you have not already. And we're going to say sleep for 5 seconds. Now when we run this, it's going to take 5 seconds. It's going to launch our driver, go out, check the price, and print it down here in our console for us. And then once it gets done doing that, it's going to wait 5 more seconds, and then it is going to launch the browser again and check the price for us. And it will do this for all eternity because we are inside what's called an infinite loop. There's no way for this loop to end, and so it's just going to keep on going and printing for us the price until we stop the program. So this isn't really helpful for us in the world of hacking, so we're going to stop here. I just wanted you to get this concept down of using Selenium, setting up functions, using a while loop. If we were to use this completely for our daily use, we would have to make an if statement and say if the price is equal to or less than $38, then we would import another module and we would have it send us an email or a text message saying the price is ready for us to go and buy it. But we're not going to finish this out because it's not really going to be helpful for us in the world of hacking. So we'll move on to building our actual tool for hacking. Okay, I have cleaned out my text editor here just to get it down to the bare bones of what we are going to need as we build this tool. I have put this right here. This is the GitHub repo that we're going to be going through and dumpster diving for. Now this should work for any GitHub page if we program this right, but I made this GitHub page just for us to test against to make sure our tool is running. I didn't want to spam an actual GitHub account that is in use, so this is just a GitHub account that I made for the purpose of showing you how to build this tool. So what we're going to make in the end is a tool that when we run it, it runs what target would you like to run against. And so we're going to copy the URL of the GitHub page that we want to scan. And when we run it, it's going to go out to GitHub. It's going to click on the repo. It's going to click on the code. It's going to go to the raw, and then it is going to tell us a password was found inside this page. And so what you could do is just copy this or click on it, and it will take you to this GitHub page, and you can search for where this password was used. So we're going to make a very basic program just like this one, and I hid a lot of the code. It's down there. I didn't want you to get a head start. So as we make this tool, when we're done, it's going to be very basic, but I would challenge you to make it your own and add to it different files that you want it to search for different keywords. Make it print the entire line where the password's found, so you don't actually have to go out to this page and check it. These are things that I've done with my tool that I've made just like this. And so I want to show you guys how to get started making this tool and then add on to it and make it your own. Okay, as we go through building this tool, there are a few things we're going to do at the beginning that I'm going to tell you to change at the end to make the entire tool work well for you. So what we're going to do at the beginning is we're just going to get rid of this right here because we want to put in our repo that we're going to be scanning against. And I'll leave that GitHub repo up unless it ends up getting taken down by GitHub because it is getting scraped over and over and over by people from all over. But until then, I'm going to just leave this GitHub page up for you guys. So we'll just put that inside of our GitHub page, and now we can comment this out and it should open up that page for us and then quit. And it did. So there it ran. And what we're going to do in the end is we will change this and we will make this an input, but we're going to cover that at the end when we get to that section. Now that we have it, so it'll open up this page for us, we want it to grab something for us by an element. And because usually there's a bunch of repositories in here, we're going to just use the repositories instead of getting the element by, let's say, the class name. Get the element, we're going to make it get elements by class name, and I'll show you what I mean in just a second. So we'll go in here and we will say we need this class titled repo. Okay, and this is what these will be titled as for us, and we have this anchor tag right here. So what we're going to do is we'll do the same thing we did in the last one. We're going to say that the repository, and we'll name this as, we'll call this our res for resources, and we're going to turn it into a variable, and it's going to get for us all the repos by the class name. So we'll say driver.find element, and then we want this to be an S. And the reason we want this to be an S is because we want to find all the elements and we're going to store them inside this variable. Now for this cause, there is only one right here, but this should work with many repos if you scan a GitHub page with many elements with the class name of repo. So we'll continue and type in by.className. We don't want a class, we want the class like this. Class name, and the class name is repo, just like this. Now if we run this, it will go and it will click this page and then it will close. So what I want to do is I'm going to add in time.sleep, and we'll make this 2 seconds so that we can see what's happening, and then we'll make another time.sleep right here so that you can see that it clicks onto the next page. So we'll run this. It's going to open, wait 2 seconds, and then it's going to open this repository right here and close. So now what we need to do is make a for loop so that way we can print the repos that are on this page. And in this case, there's only going to be one, but we're going to go ahead and make this for loop, and we'll say for I in all these listed resources, we want to print, and we want to print I. And what we would do here is we'd say print I.text because we want to see it in the text format, and then it will quit for us. I should have gotten rid of the sleep for us, and I see I spelled that wrong, and that's okay. I made that repository late at night, and it's all right that it isn't quite right. It's still a repository and we can still scan against it. So it prints for us this repository right here. So now that we know, we can loop through all of the resources that have the element class name repo we need to figure out how can we click on those. And there is a click function that we're going to use later. But right now, I want us to go through and see how we can do this a different way. It's going to be a little more complicated, but it's always best to know there are multiple ways to do something, especially in the world of coding and in the world of hacking. All right, because we're not going to use the click function, we need to see what happens when we click on this link right here. Now, this is something in cybersecurity that you're going to need to always do when you're testing a page. Not that we're testing GitHub, but when you test a page, it's always good practice to click and see what happens, how to use the page to see what's going on. And what we're going to do is check out this URL. So this is the URL that we start out with, and since it just changes the repo name as into the new directory, what we're going to need to do is take this directory and put it into a new link and get our WebDriver to open this up. Since we know we can run this, and I'll go ahead and comment out these times sleep because we don't need those no more. Since we know we can run this and we can get it to scrape all of the repositories and then print them down here, now we can just save these into a list, and then we can loop through that list and get it to append that to our URL. This is a little more complicated than the click function, but it's helpful because we will need, so that way we can get it to open every single repository that we go through in the future when we go through a page that has a lot of repositories on it. So what we will end up doing is making a list, which you've seen in the past. And if you want, you can pause the video and see if you can figure out how to make a list on your own if you remember. And so I'm just going to name our list as links, and we're going to make it empty. And what we are going to do now is we're going to take this and we're going to say links dot append, which I don't think you've seen before, and we want to append I. So now if we take this and we move it over and we print, we need to append I.text, so that way we get it right, I.text. And now we print the links right here. We should get the repository to print from our list. So we'll run this and give it a test. And it says we have repository and we have the brackets, and it is inside the list. So what we will do now that we have this list is we're going to make another for loop, and we can comment this out because we don't need that to print every time. And in this for loop, we're going to name it for L for the links. Inside the links list, we're going to make a new variable, and we're going to call it next page. And this is when I tell you my variable naming becomes very poor because I'm not very creative. And we're going to make this an F string, and we're going to call the repo. And if you remember, and we're going to call the repo, but we need to first name it something. So we need this URL to be assigned to a variable. And so we'll just call this our repo. And at the end, we're going to change this because this is going to be an input, and we're going to make this a string, just like this. And now we have this repo right here, and we'll add a slash so that way we don't have to later. Actually, we'll delete the slash and we'll add it down here in our string. Give us some practice with that. So we're going to take this repo, and because it's a variable, it needs to be in an F string with these curly braces, and we're going to add in our slash, and then we will add in another variable, which is going to be our L. So what would happen if we had a bunch of repos? This is going to go through all of the links, which we saved right here as our resources. It's going to get all the links. This for loop is going to run through all these links, and it's going to put them into our list that we have called links. And if you remember, this is where our repositories will be saved. Now we need to loop through there, and in this for loop, it's going to loop through our links, and it's going to give us a new URL. So what this URL will look like after it runs through this second for loop is it will look like this, and it will come out with our repository that I spelled wrong, and it's going to open up this page, and it will go and click this link for us. So this is the repo we want to attack. It will click this, and it will bring us to this page. So let's go ahead and try this. We're going to run this with a sleep command when we are ready. So what we need to do at this point is store our next page in a new link. and we'll just call this our final link. So we'll just call it flink, and we will save this into a list. And then we're going to append our new URL, remembering what this one right here is going to look like, because it's going and looping through a second time of this links, and it's making our new URL that we want to test, which is going to be this one right here. And we will tell this to append. So we're going to do flink.append, and we want to append the next page, and we're going to want it to append to the next page right here. So as we have this next page, if we print this, I'll show you what it looks like. So if we print this, we can say print, and then we're going to print the flink, and we'll just go ahead and pull this back here, and we will run this, and it'll show us what our new URL looks like. I accidentally left this slash. That's okay. The browser would have just deleted this second slash. So now if we run it again, it's going to spit out for us this new link. And if you copy this link or just click on it, it will take you, we'll just click on it, it'll take you to this page. And so that is how far we have gotten. So now we have moved with Selenium from this page to the next page, and where we're headed is inside this main.py, and then we're going to go into the raw. And then we want to know if in any of this there is a password or some kind of keyword. And so I'll just show you. If we type in command find and we type in pass, we'll see this password admin. We're going to make our program go through all of these words and all of these lines inside this text and pull down the password for us. So that's where we're headed. But right now we got a few pages more we need to move. We are right now on this landing page right here. So we'll try and figure out how to make it open this page and then go into the raw and then search for the password. So we'll keep going in the next section. Okay, it is time to call our first function. So we can go ahead and comment out this print statement right here, and we can call our first function. And we're going to call it above our for loops, because we need our function to be called above where the function needs to be located above where we call the function. So we will call this function, we'll just call it a loop, because we're going to loop through all the links. So we will call it like this. We'll say loop, and then we're going to pass in the next page, because that's what we want to go searching through in this function. So this is red because we haven't declared our function, and we'll declare it up above, and we will say def, and we'll call it our loop, and then we're going to pass in a function. We'll actually just call it our next page, so that way we understand what's happening. Next page, and we have to add in our 2 dots there. And now what do we want to do now that we can get to the next page? Now there's a couple of things we need to do. The first thing is we need to open that new page. So we're going to type in driver.get, and then we want it to open that next page. So let's see what happens. We can come right here. We'll just not run the time function and have it sleep and see what happens. So we'll run this and see if it opens the page and we can see it, or it goes too quick. It went too quick. So we'll stop right here and we'll say time.sleep, and we'll sleep for 2 seconds. That way we can see if it actually opened the next page, and it opens the next page and then it quits. So now that we know we're able to get to the next page, we need to be able to open this file right here and get to this raw button. So in order to do that, what I think would be best is to inspect this link and see if we can find what these links, we'll see what specific class these links all have in common, so that way we can run Selenium to pull all the links that would hold every single file within this repository. So we can inspect this, and it will tell us this is the line. And so we'll just go ahead and click this first class and see if it works. So we'll just copy this, and now we'll need a new resource. So we'll just call it resource 2, because I'm terrible at naming variables, and if I had more time to think about it, I would probably come up with something better. But you can name it whatever makes sense to you. So if I made this tool and somebody else just saw it online, they wouldn't be able to understand what's going on because I suck at naming variables, but you can name your variables better than me. And so I'm going to let you name your own variables, but I'm going to name mine resource2 because I suck at naming variables. So we're going to go driver dot, and we're going to do a find elements just like this one. And then we're going to say by class name. This should be getting familiar to you by now. And then the class name is the one we just copied. If this works, it should be able to print for us that. It should be able to print for us this class right here. We'll see. We can actually get it to print main.py. So what we'll do is we'll print, and then we'll print the resource2.text. Okay, apparently we don't need .text. We'll just print resource2 and see what happens. And that has run, and it does need resource2.text. And the reason that this is not working is because we need it to loop through this resource that could be holding this variable that could be holding multiple links within it. So like we did down here, we will need to go for, and we can call this I if we want, but I'm going to change it so that way you don't get confused by all these different variables in our for loops. We'll call it for a in resource2, and then we're going to print resource2.text. We're going to print, instead of resource2.text, we're going to print a.text, so that way we can make sure it is printing for us the main.py, so that way we can tell it to click on main.py. So we can. And now what we're going to do is we're going to do a comparison inside of an if statement. We're going to comment this out, and instead of getting this little error right here, we're going to type in pass, so that way it will ignore the error for us, and we're going to say if the letters together is pi are in a.text, then we want to do something. We're going to say print it worked, pi is in the text. So now if we run this right here, oh, I see an error. We're going to get a problem. It says it worked right here, but the reason we get this right here is it says this is a local variable inside of this segment. So this is really not good practice. If you were working for a company as a programmer, you wouldn't do this, but we're not looking to work in a company as programmers. We're looking to use programming for hacking. And so what we're going to do is we're going to make this a global variable. We're going to say A is now a global variable and can be accessed anywhere, and it gets rid of this for us. The reason you wouldn't want to make this global, let's say we made this for loop with the I and we said it's a global. Now this I variable, everywhere we used it, is going to be everywhere in our code. So we cannot use the variable A anywhere else outside of this because we have made it a global variable. And that is really not good programming practice, but for the sake of our tool, it doesn't really matter. So we're going to use it. We'll run this and it should work for us. And it says it worked. Pi is in the text. What we'll do is we can do the same thing we did before, and we can click on this main.py and look at our URL so that the way we know how to structure it. And then after this time, I promise we'll use the click function, or the click method actually, and it'll make it much easier for us. So the way we would go about this, we'll delete this, is going to be similar. If you want, you can try and do something like this and get the next page based off of this URL that we see right here. So if you want to take this challenge, you can go ahead and do this now. And for everyone else, I'll walk you through it now. We'll call this, we'll just call it second page because I'm so good at naming variables. And then we're going to make this an F string just like we did down here. And we're going to add all this together to get that new URL. So we're going to go ahead and we're going to say repo. And let's see, what did we name this one down here? We named it, we'll just call it repo because we have the repo up here. We'll just copy this. Actually, we'll just leave this. So we'll just use the repo how it is. And then we'll just add in this right here. And we can copy that and paste it in. And then we'll add our slash for the new page that we're going to want to go to. And we'll add this variable in right here, a.text. So we'll say a.text. And now if we print second page, we should get a URL printed that looks exactly like this. And the reason we did it this way is because we're going to be looping through in this for loop all of the links, and we need these links right here. So if there was, let's say we had a main.py, and then we had a CSS, a main.css, and then we had a index.js, and then we had index.html, or we had file.php, and there's a whole bunch of files inside this program. We would want to loop through all of these files for us. So what we're going to do is set it up this way so you can add to it. So as an example would be like if JS was in a.txt, then it would do the JS instead of py for us. So that's actually a challenge for you. I'll show you how to add those on, and then I'll let you complete the tool as you see fit. So what we're going to do for now is we're just going to print this second page, and it's going to open it, and it's going to tell us right here. And we can even add in a time.sleep so that way you can see that it has worked. So it did print for us right here. Okay. So I just noticed if you click this page, it takes us to a page not found. And when you compare the two URLs, we're missing this repository right here. So what we will need to do is add in an extra repository, and let's actually see if we can just grab this next page right here. So we're looping through what would be considered the next page. Where's our links at? Okay, so we'll see if we can loop through the next page right here. So we'll add in, instead of repo, we need it to have that repository on it. So we can say next page, which is getting passed through our function. And now let's print it and see if this works for us. It's paused, and we have the repository, and if we click on it, it brings us to the next page that we want. And if we were going to add on to this program, let's say, like I was showing you, if there's a JS inside the file, so like if this is a JavaScript file instead of Python, or maybe we want to check for JavaScript and Python, and maybe later we want to add PHP, we can do that. And so we can say a.text, and then we can say right here, we need to close this off, and then we could say this exact same thing, and then we would print whatever it is that we want to test for. So we would say we're going to go to a new page. If a JavaScript is found, then we're going to do this, and then we can we would turn this into an elif, and it would say, okay, there's no JavaScript file. So because there's no JavaScript file, we're going to check for a Python file. And so we'll go ahead and run this, make sure we have no errors, and it's going to pass this JavaScript file, and it's going to go straight into the Python file for us. So we run this, and it passes this right here, and then it closes and it pulls down the main.py. So what you would do if you wanted to make this a comprehensive tool, you would say if there's PHP, if there's JavaScript, if there's a JSON, and any other kind of file that you might want to check for sensitive data. But because the repo we're working with to build this tool doesn't have any of that, I'm going to just leave it with Python, and I'm going to challenge you to make the if statements and the elif statements and the else statements all on your own, and maybe you can go look at repos and see what you want the program to open up to look for passwords. Now that we know that works, we're going to comment out this sleep function because we don't need it. We also don't need it to print the second page. What we're going to do now is we're going to call a second function inside of this function. So it's kind of getting like the movie Inception. We have a function that we're calling inside of another function, but we're going to do this one in a much easier method. So we're going to go ahead and we're going to call this one function is going to be called going for raw, and I'll show you why I'm naming it that. Going for raw. This is going to be the best variable name I have ever come up with. And then we're going to pass in the second page, and then we'll make the function up here and we'll call it def, and we're going to call it going for raw. We'll call the function, we're going to pass in second page. This is actually going to be the third page. We might actually change this inside here, this parameter, in just a second. So what we are going to be doing is going for the raw. So now that we are able to get to this page, we want to click this button. so that way we can get to this page. So in order to click this button, it is going to be so much easier than what we've been doing as we've been editing this right here, the URL, and adding to it. What we're going to do is just click the button. So we can inspect this right here and see, where is it? We'll inspect, see if it can pull it up for me. Okay, now that we have inspected it, and you can see when we hover over this right here, we can see this raw button. So now what we need to do is the same thing we've been doing, and we need to find a class and see if we can find a class that is used only with that button and get it to open up this raw, so that way we land on this page right here. We're just going to copy that class name that I just showed you right here and see if that can open up this tab for us. So now under this function, what we're going to do is we're just going to say, we're going to type in raw equals, and then we're going to say driver dot find elements. Actually, this time instead of elements plural, we're going to do just one element, and we're going to say by dot class name, just like we have been, and then we will type in, we'll paste in our link right here. And now what we're going to do is something really simple. We're just going to say raw dot click, and it's going to click that button for us. And then what we'll do is we'll come over here, we'll click this. Okay, now that we're able to get to this page, we're going to tell it that we want the page source. We're going to want it to right click and say view page source, and then we're going to grab all of this inside of an F string and then see if we can find a password in it. And what that's going to look like is something like this. We want the HTML, and we're going to say driver dot page source. That way it grabs the page source for us, like I just showed you, as the same as right clicking it and view page source. We want it to grab that, and then we're going to put this into an F string, and we're just going to change the HTML. We'll just use that same variable, and we'll say HTML is going to be equal to this HTML inside of an F string, because we want it to be converted into a string. So we'll say HTML. So now we have this in a string, and just to check it, we can say, and just to check this, we can say print, and then we want to print HTML. And now when we run this, it's going to print all of that page source for us into our console, and we want to make sure that it is in a string. We have an error. Let's see if we can find the error here. We need to use driver.get, and then we need to get the second page right here. So now if we run this, it should work. And it clicked the button and it printed all of this for us. And let's see if it printed. Here we have the tags for us. And now that we have this printed, and it's printed inside of the HTML, so we know we grabbed the entire page, we can close out of this. We don't need this print statement. What we're going to do now is really similar to what we did down here. We're going to say if the password is in HTML, we want it to print found password. So we'll say print found password. And now we can run this, and if it finds the word password inside of the HTML, it's going to print found password. And if we wanted to, we can turn this into an F string, and we can get it to print for us the actual URL where the password was found. And we can say something like this. We'll make this an F string and say we want to print second page. So it'll say found the password, and it'll print the page for us. And we could click on this second page and go to it. We're getting this error here because we need to put this inside of our string. So if we print this, now it'll tell us it found the password, and it'll give us the page to go to right here to check and see what is the context of this password. Now to finish off our tool, so that way we can scrape any page on GitHub that we want, remembering that we have to get to the page like this. We can go ahead and copy this, and we're going to make an input, and we're going to name our input scrape, just like this, and we will say equals, and we're going to make this an input, and we're going to say, what page would you like to scrape? Just like this, question mark, space. And now this scrape we're going to pass into our driver.get right here. So we will pass in scrape. We're going to have to make this an F string, and we'll say scrape, and then we'll highlight it and put it inside curly braces. And now when we run this, it should ask us for an input. What page would you like to scrape? And then we put in our page, making sure we remember the HTTPS. And now when we run this, it should run the page for us. And now you can run it against other repos, and it is a complete tool for you. If you have any suggestions on a tool that you think we should build next that shouldn't be too difficult for us as we are just learning Python, please let me know down in the comments. And if you have made it this far in the video, please like and subscribe. Welcome to my crash course on Bash. This is not a complete course. I am currently working on a complete course in Bash for hackers that is going to be really comprehensive and more focused on if you want to learn how to become a Bash programmer, or how Bash programming works if you were to work in a company and you needed to know the Bash language. This course is specifically for those who want to be able to modify exploits and be able to be an effective penetration tester or ethical hacker and know the Bash language well enough that you can modify exploits and maybe even write some of your own scripts so that you can accomplish all your purposes in the Bash world. I know that is hard to believe you can do in the short span of 45 minutes, but that is the goal of this course. So if you are interested in the more advanced course, it is coming, and you are welcome to subscribe and wait for that course to come out. But in the meantime, enjoy this one. All right, welcome to our Bash scripting course. We're going to start off with the download of Visual Studio Code. A lot of people like to just write Bash scripts inside Nano or gedit or Vim, but I don't think that's very useful for you as a beginner, because we're going to use a few plugins that we can install on Visual Studio Code. So you can go right here to the link right here, which is in the description, and you can click this download right here, and you can click it, and then you can click download. If it doesn't go, then you will save and say, okay, I have already installed it, so I'm not going to download it again. It will look like this when it's downloaded into your downloads. Okay, and then the command that you will need to insert into your terminal is this one right here. So you will be in your home directory, so you will cd over to your downloads, you will ls, and you will see this right here. You will type this into your terminal right here and then hit enter, and it will install. This might take up to about 30 seconds, but I have already installed it, so I'm not going to run this right here again. And just for reference, if this is not the exact same file that you have, you can just type in sudo apt install, and then you can type in your slash, and then just start to type in code like this, and then hit tab, and it will auto complete that for you, so you don't have to go through and type in all of these numbers in. So once that is done installing, you can come over to the drop down and type in Visual Studio Code, and it will be right here, and you will launch this, and this is where we're going to be writing our code. Now, some of the plugins we're going to be installing is Shellcode, and you can come over to your little bar right here, and you will click this one right here, and you're going to search, and we are going to search for shell check, just like this, and install this top one. You can click it. I already have it installed. You'll be able to click install just like this right here. Then we're going to use shell dash format just like this. It'll look like this, and you will click install. Then we're going to want shellman, and it is right here, and you will install. And then we want bash debug just like this, You can click on that and click install. And now our text editor is up and going, and it is ready for us to open up a file and get started. So now what we're going to do is make a folder on our desktop. We can come back to our terminal and type in cd desktop, and now we can make a directory, and we'll just call this bash, and then actually we're going to name that something else. So we'll move bash and we'll call it bash scripts. And now if we ls, we have bash scripts right here, and we can cd into bash scripts, and then we can touch, and we'll call this file.sh, and we're going to name a bunch of different files as we go through and write programs. This is just to get us started. So now we'll open our folder, we'll go to desktops, we'll go to our desktop, bash scripts, and then we'll want to open up the whole folder, and it will have our bash file in here. Now in order to get this started, we'll just type in bash and hit enter, and it's going to give us our shebang up here. Without going into too much detail here, what we're going to do instead of running the default that our plugin uses for us is we're just going to run a bin bash, and you're going to see this a lot, and I don't want to confuse you with a bunch of environmental variables. So we're just going to run bin bash, and if you want to, you can go read about why we would run bin bash instead of user bin env bash. And so this is how we're going to run this. And then just to make sure everything is working, we can type in echo and then say hello world, and then we'll hit command save. And after we type in hello world, we'll come down to our terminal, and this should be in our bash scripts. You can ls, and it'll tell us we have our file right here. You can type in bash file.sh, and it prints hello world for us, so we know everything is up and going and ready. All right, now that we know we have everything working, let's go ahead and cover a few things that we have typed in here. So when we see this right here, this is the hash and the exclamation point, which can also be considered as a hash, and a bang, which is where the shebang comes from. And this tells the Linux machine when it runs this file, it's going to be running it as a bash command. So that's why when we come in here and we type in bash, and then we run this bash with this file, it's going to execute everything after this as bash. And so then we have this echo, which if you're familiar with Python, it looks like we would run a print statement like this, and then we would put our text in here, and then we would say hello world. So the echo is the same as the print in Python. And so when we run this, that's why we have this hello world printed out at the bottom. Now, there's a couple other things I want to cover just to help you as you go along and you make notes. Sometimes we'll write scripts and you might not remember, okay, what is the echo command? You can make what's called a comment. On a Mac, you can press Control and then the question mark or the slash, and then you can type anything in here. And this is commented out, so it won't show up in the file. So we can say echo will print the text. And then when we come down here, when we save it, and now if we run it, it'll say hello world, and this does not get printed no matter how many of these we have in here or on however many lines. It will not make a difference. So when we run this, this is all commented out. So now that we have a basic understanding of what's on the screen, we're going to move on. The first place to start is with variables. Variables store data, and it can look like this. So we're going to name it just var because it is simple for us to understand that it is a variable, and then they will go inside of quotations because it's going to represent a string, and you can put your name in there. So if I put in Ryan, you can think of the variable as holding my name Ryan. So if I decided to echo and I wanted to not echo an array, and I wanted to echo out the variable, we put the $sign just like this, and then we type in var. And if I wanted to say hello like this, and then var, and I need a new terminal, which is right here, and we can come down here and we can just say bash file.sh, and it says hello Ryan. So this seems really simple, but you will need to grab variables. They are super important, and we will be using them all the time in the programming world. So right now, as you look at this, you think this seems very silly. Why wouldn't I just go like this? That seems like an awful lot of work. Why wouldn't I just type in Ryan? And the reason for that is because you may need to take an input at some point later on. We will do this. But for now, we're just going to type it in here. We could just put in an IP address. So we could say IP address right here. I'm not going to put a real IP address in there just for the sake of this video. And down here, you can type in map. And then you can say -a, -p-, and then now where we would normally put the IP address, you can just type var, and then we'd put a -v for verbose. And now if we save this and run it, we would get the variable would be the IP address. So if we had an IP address in here of 10.10.10.10, and we ran this right here, it's going to start scanning this for us, and you can see that scan started. So variables are really important because later we could make a complete recon tool. We could ask the user when they run the file, what IP address would you like to scan, and we would put in this, and then our variable, whatever the user puts in, would be stored and our nmap would run. So that's an example of how we would use a variable in the world of hacking. You will see this all the time in exploits. When you grab them off of exploit DP, they'll ask for inputs, which will be stored in variables, and maybe in the future you will need to modify them. So that is a variable, a very simple version of a variable. Okay, so one of the reasons I struggle with Bash so much is because the way they name their functions. For example, in Python, if we made a name, and let's say we had an input and somebody input their name like this. If we wanted this to just be all caps, we would just put .upper at the end of our function call or $lower. But in Bash, we do it a little different. I noticed this is supposed to say name. If we echo this and we say echo $, parentheses, and we say name, and then we don't forget to save it, and we run this, we get my name output here. But if we wanted to get just the first letter capitalized, we would put in a caret, and then we have to save it. And now when we run it, my bad, we need a double caret. I forgot to save it. Now when we run it, we get all caps, just like this. And then if we wanted all lowercase, we just put in two commas, and we can save it and run it, and now we get all lower. So in the world of Bash, when you need to do something, if we don't cover it in this class, you may have to Google just to see exactly how to run this. But this is really helpful because a lot of Bash commands and a lot of Bash scripting is going to require all lowercase or all uppercase. So for example, a lot of times when you run against an Active Directory name, let's say you have the Active Directory name, a lot of times they will be in all caps, and you can use the double up caret just like this if you're running a script against it and you don't want to type it, and you get all caps. So that's an example of when you would want to use something like this in the world of hacking. And there's a couple other things that might be useful for you that you can do. If we wanted to, we could come in here and we can put in an exclamation, or sorry, we can, if you wanted to, you come in here and put in a hashtag. We can save this and run it, and we get the length of the output. And with this word count, we can use this later. Let's say if we have a list and we want to know how many items are in a list, we can use something like this to check what is going on within the inside. And lastly, there is something we're going to need to know in order to grab numbers, or in our case, we may want to grab something out of a string, and we want like every third word would be beneficial to us to grab. If we have something instead of name, let's give this as num equals 1, 2, 3. Actually, we'll start at 0 because Bash, all programming languages start at 0 when they start counting. So if we come down here and we echo, we say $, our parentheses, and then we say num, we should get our number. our string of numbers put out down here. But if we wanted to grab numbers out of here, we would do something like this. It will be the variable right here. So we'll have the variable and then the offset, meaning how many over would we like to start. And then we have the length, meaning at what number would we like to stop. So in here we can say colon, and if we wanted to grab numbers 1 and 2, you would say 0, 1, 2. So a lot of times you won't start at 0. So for example, we would say 0, 1, 2. So if we wanted to grab the 2 and the 3, we would say something like this: 0, 1, and then 2. And then if we save this and we run our file, we get number 2 and 3. But for the sake of this not being super confusing, we'll start with 0, 1, 2, 3. But what you just have to remember, in the world of programming, computers start at 0, and this is our number 1. So 1, 2, 3, just like this. Or in this case, it'd be 0, 1, 2, 3. And if we got rid of this, we would have to say 0, 1, 2, 3, and so on. So I hope that makes sense and you are able to grab numbers out of this string, and maybe you can go ahead and try and practice with grabbing numbers. You can also do something like this. You have to have a space in order to run a negative offset, but let's say we wanted to go backward 4 and then we want to grab the next 2 afterward. We can save this and you can run something similar to this, and you get a totally separate set of separate numbers. And I do use this every now and then. It's not super common, and you might see it in the future, so it is something worth noting and keeping it in your back pocket. Okay, I want to show you that we can save commands inside of variables, and then we're able to run them inside of our scripts. This will be helpful in the future. So you're probably familiar, if we come down to our terminal and we type in pwd, of seeing our present working directory. But we can save commands inside of scripts and then use them. So for example, we can say directory equals, actually we can say current, we'll say cur-dirs for our current directory equals, and then we say $, and then we put our parentheses and we say a pwd. Now if we come down here and we echo a variable and we say current directory, just like this, and we save this out and then we run our script, we get our present working directory down here. So another example of this is if we said time and we said equals, and then we put in date inside of here, we could say echo, and then we want to echo a variable, but before that we could say the current time is, and this is going to give us our time and date. And if we save this and we now run our script, it tells us that we messed this up because we didn't write in the time right here, and we save that. Now we run it, it tells us the current time is Saturday, June 4th at this time. So that's how we can save commands inside of variables. And this is going to be helpful in the future whenever we have to write specific scripts and use them with commands that are already within our Linux machine. So from here, we're going to move more into working with numbers, and the numbers will matter when dealing with things like IP addresses, or sometimes you may want to print a word list that you want to use as with a fuzzer that has numbers on the end of it. And we're going to be covering this in the coming up section. Okay, we're going to be covering some numbers and adding them together and using a sequence of numbers in order to grab a range of IP addresses or possibly even make a password list with numbers. But with Bash, this is a little different than other programming languages. So you can either take this whole block right here that we've already written and comment it out, or you can just delete it like I'm going to. If you want to, you can save it and keep it as notes for later. So within Bash, if we say something like other programming languages, x equals 4, and then we say y equals 8, and then we echo. And the thing about Bash, when we want to add these together, it's going to require a little different syntax than you might think. So we use $, then we have double quotes, and then we would say $x plus $y. And now if we save this and we run it, we get 12 down here. And I believe within Bash, you don't even actually have to have the $, so we'll give this a try right here, and it still gives us 12. And this works with also, we have minus, and you can run divide and other commands like this. So if we run division, we have 0, which is right because 8 doesn't go into 4, and Bash won't give us any decimals, and it won't give us any negative numbers, which is really interesting. So if we say y minus x and we save this, we now get 4. If you want to run something such as a calculator within Bash, you have to use BC, but I'm not going to cover that for the sake of this course. I would rather tell you just use a calculator because it's going to be a lot easier than using the command line to run some kind of math. So this is how we would use variables and numbers within Bash, but when it becomes useful for us is when we want to create a list of, say, numbers. So if we say echo month, and then we put curly braces, and then we say 1.12, when we run this command, it should print month 1, month 2, month 3, and so we'll save it, and I'll show you what this looks like. So we have the output like this, and this may seem like it's not very useful in the world of hacking, but let's say we have an IP address, and we want to create a list to scan against in the future, and maybe we're creating some kind of tool that is going to take an input of an IP and the range. We could say we have a subnet of a 124, so we'd say 255 through 1 through 255. Then we save this, and then we run it. We now have all of these IP addresses. I forgot to put a point right here, and now we'll save it and we'll try this again. And now we have all of these IP addresses, and we have this list that has a complete range of IP addresses for our range. So this is a helpful way to know that we can append numbers to something preceding it. So this will be helpful in the future. I don't use it a whole lot, but it is helpful to know that it is available for us if we ever run into any kind of problem. Okay, I want to cover something called special parameters because it is something you're going to run into in the world of cybersecurity. So we'll clear this and we can comment this out. And the reason you're going to run into this is when you run a tool or some kind of exploit that requires input from the user, say us. Whenever we want to run this, it'll ask for a IP address that we want to attack and a port to connect back on. You may see it say that you didn't enter everything required. And an example of this is if we say if, and then we go square bracket, and then this right here is a special parameter. So this is going to tell us that we need right here 2 inputs from the user when they run the file. So we have this if, and then it's going to be a then, and then this will be tabbed over, and we'll echo need more parameters, and it'll tell us echo usage needs 2, and then we can give it an exit of 1, which means we have an error. And then for Bash, instead of an if else or an if or an elif like Python, it uses an fi, and we can run it like this. So we should be able to now save this. Okay, we should now be able to save this after putting in those spaces, and it should run for us. So if we run this, it'll tell us you need more parameters. But if we run it and we say, let's just use 1 space 2, these are going to be 2 inputs from us, and we run it, it doesn't give us any issues. In fact, we could have it print script worked, but in this case we'll just leave it so that way you can see we didn't get any exit code. It needs 2 inputs from the user in order to execute. So with that, this looks really scary, but really what I wanted you to see was this is the special parameter that tells the file that we need, that bash will tell us that we need 2 inputs from the user in order to make this script actually run. So these are special parameters, and they are going to be one of those things that if you want to memorize them, I would suggest, which I rarely ever suggest things like this, is flashcards and memorize. Usually when you're in the world of programming as well as cybersecurity, you would just say, I know there's a way to use a $sign in order to get to inputs from a user, and I just need to know it, and later when I run into this, I can just come back and Google how to do this and read how to do it. It saves you a lot of headache and a lot of time memorizing, because you're probably not going to use this very often and will forget it. But it's important to know that this exists, because maybe in the future you will run into an exploit that has something like this, but the exploit is old and maybe it has been deprecated within the version that we're running our exploit against, and we need to get rid of one of the parameters. You now know that you can come in and say, instead of 2, let's say it had 4, and it has been deprecated and it no longer needs 4 inputs, it only needs 3. You can come back and just put in 3, and now you can run the exploit as you need. So this is the reason I would suggest trying to remember that this $sign hash has this specific special parameter function, because it is something you may run into in the future and need to know how to modify. We're going to ignore the if statement for now, and we're going to look at a different way to take input from the user, and that is with the read command. So you can just say something like this, read, and then we can say maybe we want an IP address and we want a port number. We'll just leave it at that for now. So we can go enter, and then we could say something like echo. It is going to be with a variable. The variable is IP. Then we can come back here to the front, say something like the IP. We'll say the target IP is, and then we'll have that IP, and then we'll say echo with another, that was with the text. That's okay. We can just add our variable in later. We can say the connection port is, and then we'll go $, curly braces, accidentally 2, curly braces. We will say the port, and then close off our curly brace there. Now, one thing that you're going to notice is why is our variable not lit up? And the reason is because single quotes get rid of every special character inside of a string, and double quotes will leave all variables alone. So that is something to note for the future. So now if we save this and we come down here and run our file, it's going to leave a prompt, and we could say the IP address is 10.10.10.10, and then the space puts us onto the second variable, and we'd connect back on port 444, and then we hit enter, and it tells us the target IP is this, and then the connection port is this. Now, there is a better way to do this, and what we could do is something like this. We'll delete the port, and we can put a -p, and this is going to give a prompt to the user, and we'll say input the target IP :space. We'll add a space in here, and now we could say read -p, and then we can do the same thing and say input the connection port :space, and then we can come in here and put in port. Now if we save this and we run it again, we have a prompt down here, and then we hit enter, and then it asks us for a connection port, and we put in our connection port, and then it prints out for us the target IP port, or the target IP and the target port. So this is how you take input. I like this a lot better because it is user friendly, and it's really simple for us to read what is going on, and this way we cannot skip, say, an input. And if we put in an empty input as our port, then we would have an error with an if statement. And we'll cover that in the coming section. Before we move into our if statements and loops, we need to understand conditional statements or conditional operations. So we will comment out this code right here. I hit the wrong button. We'll comment out this code right here, and we will see things like this. You'll see a -eq, which is going to be an equal to, or maybe we will see something like a -ne, which is not equal to. You can see something like a -gt, which is going to be a greater than. I'm going to go ahead and comment this out so it stops suggesting things to me. So we'll see a -eq, a -ne, the -gt, which is greater than, and then a -lt, which is less than, or a -geq, which is greater than or equal to, which is the one we probably will be using the most, and then a -leq, which is less than or equal to. These will be really helpful when running our for loops, and so it is helpful to know. So let's give a look at these in action. So the way we would write this is if we wanted to give a statement, we'd put our brackets, and there has to be a space in between the bracket and the first number. So we would say if 2, and then we'd say -eq is equal to 2, then we're going to have it do something, and we would tell it to echo that the statement is true. And the way we would do this is by adding the colon and then say echo and then $, and then question mark. And the reason we're using the $, question mark is because it's going to return a Boolean. So a Boolean is something that is going to be true or false. So it's going to return true, which is going to be equal to 0. And if you're from another programming language, then you will know this is not normal for most other programming languages, but Bash, true is 0 and false is going to be equal to 1. So this is going to return true or false in the form of a 1 or a 0. So when we run this, we'll save it, and now when we run this, we should return back a true statement. 2 is equal to 2, but if we change this to 3 and we save it, and we run it, we get a false. This is not true. So this equals right here only works with integers, which is numbers. It is really important to remember that it only works with numbers. So we can do something like this, and we can say not equal to. So is 3 not equal to 2? Delete this, and it returns true. So we have this true given to us right here. When we run something like is 3 greater than 2, and we'll save this, we can run it and we get a true. Is it less than 2? And we will get a false. This is really helpful when we run our for loops. In the future, you will run into this, you're going to see it, and is something to be aware of. Okay, we can also look at conditional operations for strings. An example of this would be, we'll uncomment this, would be something like this. So we'll use an equals, and we'll say the word is equal to word. And now if we save it and we run this, we get it is false because I spelled it wrong. Save, and we run it and we get a true. So this equals is used for strings, and if we want to say a not equals, you put a bang in front of it or an exclamation point, and then if we save and run this, we will get a false because it says they're not equal, but they really are equal. So if we take off the end of this word, save it, and we run, they are not equal is true. So this is helpful, especially if you're running a script that you are looking for a specific keyword within a text that has been fed in through an input. You can check to see if they are equal and then have it do something afterward. So now we're going to move on into if statements, and we're going to see how this plays into writing our if statements. Statement off of what we already have here. We'll just make this a word, and we'll make this equal to. And then the way if statements work is you start an if statement with if, and you can also use and else, but when you're done with the if statement, you write in fee, just like this. So we can do if this is true, then do this portion of code. Else, if it's not true, do this portion of code, and then when the script hits fee, it will exit. So if we come in here and we just say if word equals word, we're going to tell it then we want it to do something. So we can come down here and say echo, and we're going to use echo a text, and we'll tell it to echo words match. And then we can come down here and tell it else. We can do an else, and we can tell it to echo a text, and we'll tell it does not match, just like this. I accidentally clicked the debug, but we're not going to mess with that right now. And then we're going to close this off. Now, if we save this, come back to our terminal, and we run the file, it tells us the words match. If we get rid of our D again, and we save, and we run this, it says they do not match. So this is how you can use a comparison with an if, then, else, fee statement. So if it is this, then we want it to do a specific function, and if not, then we can have it do something else. This is a very basic if statement, so I would challenge you to change this if statement and see if you can do an if the number 2 is equal to the number 2, then you want it to echo the numbers match, else they do not match, and then do the same thing with a not equals, and just work your way through these and see if you can play around with the if statement and really grasp these concepts and make them your own. We're going to be moving on to while loops, and we're going to cover these really quickly because we won't use these a whole lot, but an example of when a while loop is used is in a buffer overflow. When we want to crash a program, we're going to send it so many bytes until it crashes. And so the example is we're just going to say while this is running, we're going to send bytes to the server until it overflows. So while loops are used, but I use them very infrequently. I don't use them often. I know there are other programmers out there who love while loops and use them all the time. I would much rather use a for loop. So for that purpose, we're going to cover while loops really quickly. So while we're in our file here, we're going to write a while loop, and we're going to use a really common while loop that is used pretty much in teaching while loops, no matter what the programming language is. So if we take an input from the user like this, and we say enter a number, and then we do our colon space, and then we're going to assign it a variable of num, just like this. And then we say while the condition, which is going to be the num, is, we'll say less than 10, we want to do something. So down here, it tells us we need to enter in what we want it to do. So we want to echo or call out the number for us every time the while loop runs. And then down here, we need to make sure that our number continues to go up. So we'll say num equals $, and down here we will need 2 sets of parentheses, and we will say $, num plus 1. And the reason we're adding in this plus here is each time the while loop runs, we're going to add 1 to the number. And so the first time the loop runs, let's say we enter the number 0. It will run through the while loop, and then when it hits this line of code, it'll be 0 plus 1. The second time it runs through this loop of code, it'll be 1 plus 1, which is 2, and then 2 plus 1 is 3. Every time it runs, it's changing this variable. So what we are going to do is save this and run it. We'll run it a couple of different times so you can see how this works. So let's say we enter 0 as our number. I have an ls here, and that is not it. It is a less than, which is an lt. So we'll save this, run it, and our number is 0, and it shows us it runs 1, 2, 3, 4, 5, 6, all the way down. And remember that it starts here at 1, 2, 3, and here we go. So it runs for us from 0 all the way to 10. Now, if we run it again, and let's say we put in the number 8, it only runs twice, because 9, when it hits 10, when the number equals 10, it is no longer less than 10. So now that we see how the while loop runs, we can also do something like this. If we enter in a number that is already greater than the number 10, it will just exit the code because it is no longer a less than. So this is an example of how a while loop runs over and over and over until the statement up here is no longer true. Now I would challenge you to use this with a greater than and maybe change this to a minus and see if you can use an input of a number and say that you need this to be as long as the number is greater than 10, you want it to do this, and then you're going to minus 1. And so you can kind of play around with a while loop and get an understanding of how it works. All right, I have typed out a for loop here for us, and this is a very basic for loop. So we have this for loop here in for. We have this for is how we're going to start it. I, which is going to be the variable, which iterates through the list that we give it. So we're saying for I in this list of numbers, we want it to do something, and we want it to echo out the variable I every time this loop runs. So the first time the loop runs, I will equal 1. The second time it runs, we'll put a 2 in here. The I will equal 2. The third time it runs, it's going to equal 3, and so on. So if we save this and we run this file, you can see I echoes out 1, 2, 3, 4, 5, and so on. So every time we use something like this, and so this is the for loop, and you can play around with the for loop in a lot of different ways, and even use these to loop through lists or arrays in order to get it to print. But the point of this course is not for us to learn how to program with for loops, but rather understand them and know how to edit them as we go through our cybersecurity journey, remembering that the point of us being able to understand Bash is not to be Bash programmers, but in order for us to know how to manipulate Bash scripts that are already written, as well as Bash exploits. So when you see a for loop like this, you now know how you can edit it and change it. And if you need to, you can write simple Bash for loops and loop through different arrays and lists.